Hey everybody, welcome back to Extreme IE. In this video, we are going to talk about Kubernetes. Now, before we jump into Kubernetes, obviously you can read the one title that I have here on the slide. But before we jump into this, I want you to take a step back. If this is the first video that you're watching about the container series that we're doing, I want you to think about VMware, right? Imagine that you have, let's just say in this case, 3, maybe 4 ESXi servers, right? So you have VMware deployed and you have ESXi servers in your environment. How much of a pain would it be if you had to connect to each one of these servers in order to orchestrate a task? Right? So keep in mind, these are where all your VMs are running, and you have to go in and you not only have to deploy each VM individually, you have to manage these, so you're having to connect into each individual server, you're having to write all of your different APIs and then connect each API to each physical server. I mean, when you have 3 or 4 servers, that's pain enough, right? Imagine if you had 100, right? Imagine if you had 10,000 VMs that you had to span across, let's say 200 different so we'll say multiply times 200. Imagine if you had 200 physical ESXi servers and you had 10,000 VMs and you were having to connect into 200 different servers in order to orchestrate all of your different tasks. It would be a real pain, right? And that's the reason why VMware came out with the main brain in VMware, which is what we typically call, or what is called, vCenter, right? So instead of doing all of this, you connect into vCenter, you say, hey, I need to deploy 100 of these servers, I need to deploy 200 VMs, whatever I need to do. And then vCenter kind of communicates with all the available servers, and vCenter does the rest for you. So even though Kubernetes is not the same as vCenter, I mean, it kind of is, but it's kind of not. I want you to think of it as the vCenter for containers. That is the best and easiest way for you to think of it, to be able to digest what exactly Kubernetes is. Kubernetes is the automation, the brains, the orchestration that vCenter is for VMware, except obviously Kubernetes does it for containers. So everything that we talk about within Kubernetes is going to fall under these two categories of orchestration and automation. It's either going to be orchestrating some kind of a task for us, it's going to be automating some kind of a task for us. Kubernetes is going to be, again, the main brain that we connect to in order for us to orchestrate what we want done in our container environment. So there are a lot of different things that Kubernetes does for us. I'm not going to go through them all. I mean, there's a lot of reading out there that you're going to need to do. I want to tackle maybe just the first maybe 3 to 5 things that Kubernetes does. I have some of them in my notes that I definitely want to talk about. My brain may spark and talk about something else. The first thing that I want to talk about is auto scaling. Now, auto scaling. Imagine that, we have a web server, right? So we're just going to say IIS. Imagine we have a web server, and during the daytime, we need 30 web servers that are running during the day. But at nighttime, at night, we only need 10. Because obviously at night, we have much less load on our environment. Well, Kubernetes is an environment where we can automatically create or delete unneeded containers based on that scale. So if we decide that we have a certain state of events, if we have a certain state of our containers that we want to maintain, if we have a certain number of containers that we want to maintain, what we can do is we can actually tell Kubernetes exactly what we want and when we want it. Of course, there's some programming and there's some commands and things like that we have to set up, but we can automatically scale our container environment using Kubernetes. And this leads me to the next thing, which is, I'm going to say load distribution. I'm just going to say dist for short, right? Load distribution. What do I mean by that? Well, Kubernetes operates on a principle of having worker nodes. Okay, what are worker nodes? Well, worker nodes are what you would consider ESXi servers, right? So in VMware, you may have 100 physical ESXi servers, and then on those ESXi servers, you would obviously have, all of your different VMs that are running, right? Well, worker nodes are kind of the same thing, except those worker nodes are those VMs. So the worker node is your root operating system, and then underneath that root operating system, that's where you're running your container runtime, in this case maybe Docker, and then this becomes a worker node, and so you're going to have another worker node, and again you're running Docker. Yes, you do have to keep them the same. You can't run Dockerd and then Docker and then all these other, you can't run a different container runtime on each one. You want to try and keep them the same. But these would be worker nodes, and I could have 10 worker nodes, I could have 100 worker nodes. And so what Kubernetes will do is say, hey, you know what, each worker node, this guy has a certain amount of CPU and RAM, this guy has a certain amount of CPU and RAM, and maybe just like in VMware, they're different. And so if I need 30 containers, if I need 10 containers, what Kubernetes will do is say, okay, I'm going to put maybe 5 here, I'm going to put 8 over here, and so on and so on. Just like vCenter would in ESXi, what Kubernetes is going to do is it's going to distribute the load of the containers that you need across the registered worker nodes that you have. And so it's really cool to be able to automatically load balance that distribution of resources. Now, I already mentioned the next thing that it does, which is load balancing, right? This, I want to say, is different than load distribution. Load balancing, I mean, think about you having all of these different containers in a web server environment. You have all these different containers that are spread across your server environment, and obviously you have all these inbound, let's say HTTPS requests, and you want to be able to have some kind of a load balancer in front that says, okay, I'm gonna send this load this way, etc. So Kubernetes can automatically monitor the inbound flux of traffic and say, okay, these 8 servers are being hit harder than these 5 servers, and so I'm going to go ahead and send this traffic into these 5 servers, right? So rather than having to worry about distributing physical load balancers all over the place, or even downloading, virtual, let's say, F5s everywhere, Kubernetes can kind of handle the load balancing for us and distribute not only the resources, the containers, but also distribute that inbound load. Containers, Kubernetes, and again, right now I'm kind of going off the top of my head here, Kubernetes can also register our containers with things like DNS to make our containers more reachable, right? So when we think about being able to advertise our containers or our application to the outside world, when we think about reachability, Kubernetes can help us with this as well by, again, registering or exposing our container environment to things like DNS for us to be able to reach them from the outside world. I'm going to erase some of this just to have more, I'll just pick a different color. It can also do things like auto healing. So imagine that you have, again, 30 IIS servers or 30 web servers, and let's say 2 of them all of a sudden crash, they go down. What we can do is we can actually set up a health check. Let me put it over here because it makes more sense, right? So we can actually set up a health check to say, okay, I want you to monitor, I want you to perform a certain amount of tasks, maybe make sure that you can get, inbound on port 443 to these servers. And if you can't, maybe I want you to perform some kind of automated task. So what we can actually do is we can remove that container. If that container, for some reason, it goes down, it's crashed, something happens to it, misconfiguration, whatever. If it fails this health check and we're not able to get to that container on port 443, Kubernetes can do anything from just remove that container from distribution. So, because again, remember that it's actually doing some of the load balancing for us. And so Kubernetes can remove that container from seeing inbound traffic. It can do anything from restart that container to try and auto fix it, or we can just kill it. So there's a lot of things that Kubernetes can help us do. And if we are in some type of an auto scaling environment, if we say, hey, I need to have 30 containers up and running, and all of a sudden this container fails our health check and we tear it down, well, we can go into the automatic, the automation of being able to spin up a new one. And as we spin up a new one, this allows us to do things like maybe automatically mount specific storage. So we're going to say storage allocation. So we can automatically mount some of the things that we're going to need in order to actually run that container. So I'm trying to, again, keep this video under 10 minutes. There's a lot more that Kubernetes does. I'm just trying to give you the idea that when you think about Kubernetes, I really do want you to think of vCenter. It is really a main brain that is focused on maintaining and running our entire containerized environment, not just one application, but all of our containers, all of our registered apps across all of the different worker nodes that we have, and providing us with a way to, again, automatically load balance, automatically load share, and automatically self-heal our container environment if something should happen. Hope you guys enjoyed this video. I will see you in the next one.